if you go to the next slide, Thomas, we will get started right away. Okay, so as Bibiana was mentioning, today we are going to talk about cleaning optimization, and we will see also how cleaning optimization can, let's say, help you reaching your goals. But let's start first talking about the cosmetic market, right? So we all know that it's a growing and fast-changing market. Why that? First, because in 2021, right, you all saw a global rebound of the market since COVID. So this means that you had to get back in production, speed up production, and get to the same level of before COVID pandemic, right? We also know that a majority of product portfolio is being reformulated every year. So innovation pipeline is typically very high, and there's an intense market competition. So what does it mean for you, right? What does it mean for personal care companies? It means that you typically need to increase production capacity and enhance agility. That's what you are asked to do, as well as cut costs, right? So these are two factors that are required to stay competitive. What many cosmetic companies don't really realize sometimes is how cleaning can play a role in meeting these goals. Indeed, cleaning optimizations and the optimization of cleaning can get you there quicker than you think. And this is basically the topic of today's meeting. And so we will see how suboptimal cleaning is holding production operations back. So typically, every production manager has three key goals, right? The first is to increase production capacity. And how does suboptimal cleaning prevent that? Especially in cosmetic industry, there are some difficult to clean residues that we will see together with Thomas that can create some long downtime for cleaning. And sometimes this is even unexpected, especially when new formulations are brought into production. The second key goal of every production manager is typically to protect operator safety. And how does that, let's say, play a role for cleaning? Is that if the cleaning procedures are very manual, and if there's harsh chemistry being used, this increases the risk for operators, right? And finally, the last, let's say, key goal that every production manager has to meet is typically cost reduction and sometimes sustainability target to meet, right? This can be prevented if your cleaning process takes a lot of water, energy, and labor consumption. So I will now hand over to Thomas, who will explain. So if we have a look at the agenda in the next slide, he will be explaining how you can meet your goals by optimizing your cleaning disinfection procedures. We will also see some real case examples of how to solve cleaning challenges in the industry. And finally, we will have a look at solvents and what are some of the pros and cons in using them for your cleaning procedures. So back to you, Thomas.
Thank you, Paola. And thank you all for participating. Unfortunately, we have to do this talk in English, but I hope that we are so clear that it is easy to understand. So what Paola already mentioned, we want to focus a little bit on the, I would say, practical work we are doing at our customers and want to give you an idea of what is possible. So with that, we start with the increasing and the production capacity. So increasing production capacity is really a constraint what we find at a lot of different sites today. So people are coming to us and say, we really need to produce more products, but we cannot expand to buy new equipment. We have only the equipment what is available. How can we get a little bit more produced? And then we normally start the discussion. And I really want to start now with extremely time-consuming cleaning. Specifically in the cosmetic industry, you might face this because of your ingredients you are using in your products. So in this example, I want to talk about a cream where an external oil phase is mixed with pigments, iron oxide, titanium dioxide, and so on. So the challenge was for us, there was a titanium dioxide and even a pigment film after the cleaning. And this led to very long cleanings or even to redo a cleaning. And we want to be able to bind these kind of raw materials or this kind of ingredients in the product to get a good cleaning. So the protocol today, when we started this project, was going up to 5 hours for the cleaning, including preparation and manual pre-cleaning, then doing a CIP step, then going into the manual operations again. So that was a very time-consuming and even labor-consuming exercise. So a lot of operators were busy with the cleaning. We know that you have typical residues in your equipment, like high mineral loads, high pigment loads. You have waxy ingredients, what are maybe hard to melt or even very hard to emulgate. You have silicons inside. So where we see extremely hard conditions for cleaning is sometimes needed, but also the knowledge of what is the right cleaning solution should be known to you. And how to come to that knowledge. Let us have a short look at the Cosmetic Gmp. What do they define as cleaning? They outline that all operations that ensure a level of cleanliness and appearance consisting of separating and eliminating generally visible dirt from a surface. So this is what the Cosmetic Gmp is really identifying. Get the visual dirt from a surface, meaning at the end, you should have a visual clean surface for the next production. So and even if you are doing campaigns, where equipment is assigned to continuous production or of successive batches of the same product, the equipment should be cleaned and if necessary sanitized at appropriate intervals. And this is extremely true now for products having a high content on, I would say, more green materials. So if you are talking about approaches where you want to go green-minded, there you find raw materials with a much higher germ content, or I would say microbiological load in the raw materials you are using, and you cannot use as much as preservatives as we had before. So the preservation of these products is also not very much in favor. You really want to go into a situation that you say, I want to make safe products due to my manufacturing circumstances, meaning I will do a proper cleaning and maybe even a sanitization for these kind of products in specific, because I cannot take subsequent steps to prevent microbiological growth or even to have the best cross-contamination reduction as possible. So when we come back to our protocol, what we want to develop for this really hard to clean pigment mass, we were seeing that the temperature for cleaning plays an important role in this kind of cleaning. So the 80 degrees cleaning, this is the kind of cleaning trial we are making to spike residues onto coupons, so to spike the product onto stainless steel coupons and then run a cleaning trial in our lab. And we could see that 60 degrees, so a lower temperature, is much better compared to a higher temperature. And even if we compare that to a classical food and beverage alkaline detergent, what was used on that site before, we could see a pure advantage in using dedicated to the cosmetic industry cleaning agents. So this is example lead then to the fact that we say, next to the fact that you can save energy due to the experience that the hot cleaning temperature is not as effective as the lower cleaning temperature, we can even go now into a situation that we have identified the proper chemistry, and the time for cleaning from 5 hours was going down to 20 minutes. The requirement here was to do a pre-rinse with a high concentration already of a detergent at 60 degrees Celsius. for 12 minutes, and then to do a main cleaning with a lower concentration. So the first step is to get rid of the big bulk of the mass of inside of the equipment. Then to say, if the predominant of the product is out, we will do a main cleaning with the same chemistry for a shorter period of time, and then to make a final rinse with cold water, and then to heat up the system for microbiological safetiness. We would also recommend maybe to do here a disinfection step, but yeah, as we know that hot water sanitization is often used, we cannot avoid that here in this case, and they wanted to still continue to do that. But what it brings to your attention is that there is really a big potential to save a little bit of energy and even a big amount of time. What we are doing for that is that we normally look into the different products, what are manufactured on site, and that we want to work out together with you a grouping strategy. So what kind of products are having maybe the same ingredients inside, or do have the same demands on ecological profiles of cleaning agents or whatever. In this groupings, we then want to identify what is the worst case product in this group. And worst case means what is the hardest to clean. The rationale would be, if I can clean the hardest to clean product in that group, all the other products belonging to that group would also be cleaned as well. And at the end, we will use the worst case product with a detergent and a protocol to get this kind of cleaning installed for all the other materials belonging into that group. So meaning, if you are having like the mascaras and you have different ones on site where you say, oh, I have waterproof and non-waterproof mascara, that might be already two scenarios that you say, oh, the non-waterproof mascara is easier to clean, therefore I have a specific protocol for mascara cleaning, and then I have a protocol for worst case mascara cleaning, so meaning for waterproof mascara cleaning. And each of these mascara and waterproof mascara protocols will then apply for each of the products belonging to that group. And this is a well-known type of cleaning we are doing in the pharmaceutical production, but it's also very useful for the personal care industry, not to develop hundreds of different cleaning plans or cleaning recommendations, to try to identify what products belong to a specific product group, identify the worst case of that group, and then clean all the materials using the same approach. How to identify a worst case product. And here also guidelines help to understand why you should maybe do a kind of cleaning protocol development. Because these laboratory or bench scale studies can really give you specific knowledge on the cleaning process. So remember the example we just had. There, the 80 degrees Celsius was not as effective as the 60 degrees. The cleaning process knowledge is then, oh, I should run the cleaning at a colder temperature, and I should maybe also track the temperature. Because what we can see sometimes is you give 60 degrees into the PLC of a device, and you want to have it heated up to 60 degrees, but it's overheating. So then you start the cleaning maybe not at 60, at 70, 72 degrees Celsius, because it's overheating a lot. So then the cleaning effect is maybe not the same. But you know the temperature plays an important role. This is the cleaning process knowledge you gained from this laboratory study. What we also understand is there is a difference between the full scale, so when you go on site, and the lab scale trial. But we want to help to assist to identify what we have learned in the laboratory and transfer it into the production. And therefore we can see these kind of coupon studies, what you have just seen. So where we apply residues on stainless steel coupons. Even better situation for us in a lot of circumstances is to use the beaker studies, where we have stainless steel beakers with the residue inside, and we stir it with a cross stirrer inside, so having a good mechanical action that simulates more the situation of a mixing tank or a homogenizer. And in the last instance, we can even go into a small scale mixer. So for example, we have here in our lab in Monheim in Germany, a CML4 cream mixer with lift for 4 kilos of the company Cymex, where we can run even some test batches or apply products inside and run if more or less laboratory bench scales study in a enhanced version of a 5 kilo. This kind of considerations we are having of the worst case is also then leading into the fact that we want to look into different cleaning scenarios, because we have just seen that it is a possibility outlined by the Cosmetic Gmp that you can run multiple products one after the other of the same formulation in an equipment. So to make a campaign, for example, then you are cleaning between or during a campaign. So cleaning between batches of the same product might not be the same cleaning as what you do when you clean between different products. So you're moving from a sun cream to a mascara, whatever, yeah? Or if you clean between similar products. So this is very often done when you have, for example, a sun cream production, and you start with a very low grade of sun protection factor, and you increase the sun protection factor over the campaign length. Then these products are not identical anymore, but they are very similar. They are having the same ingredients, and maybe at the end of this campaign, you will then run a cleaning. Also, you should consider, if you have dedicated equipment, how to clean that. Is it necessary to have a really good cleaning for that as well? What does visual clean mean for you? How important is the visual clean? Is this acceptable to have maybe even some residues what are very dry, like pigments on the surface, what cannot contribute to microbiological issues? Can you show that? Can you demonstrate that so that you have a good reason to outline what your strategy on dedicated equipment cleaning is? Also, if you do a equipment maintenance, how do you do the cleaning after you maintain it? You need to have maybe a kind of oil, what is needed for the equipment maintenance, what is dropping into the vessel. Is that the same cleaning what you will run also after a different product will be produced? And these kind of information. What I also see a lot of times is if you have, for example, a defined clean hold time, then if the clean hold time is elapsed, how do you clean that? Is it a disinfection only? Is it a water rinse? Or what is it? So these kind of considerations is what we want to bring to the attention, and this is also what we want to show to you and give as an information that there are possibilities even to discuss on different cleaning scenarios because of the fact that you have these kind of things. We have also identified that there are topics like dirty hold time and cleaning hold time discussed in your industry. Because if you have manufactured a product and you start the cleaning, so what is the maximum time you can hold the equipment? That plays an important role because there might be a change of the cleanability of a product when you have it in a tank for a longer period of time. Sometimes it's getting easier to clean. Sometimes it's getting harder to clean. It's really depending on the product. So a drying on product where you have, for example, a water-based mouthwash, where there's a little bit of alcohol, if this dries on, it is sometimes getting harder to clean because the pigments, the colorant is penetrating into sealing materials, and then the dirty hold time would play an important role that you say, oh, it should be maybe not longer than 1, maximum 2 hours standing empty, this equipment, before cleaning. Or you say, I have produced a high oil containing, high fat containing cream, and even if it stands for 3 days in a vessel, there is no difference in the cleaning behavior of this mass. And with these kind of considerations of, are there products where I have to focus on the dirty hold time? I have to do a quick cleaning, otherwise it's harder to remove. Or are there products where I can just let the cleaning run after a certain amount of time? That is something where we would say you can have a risk mitigation so that you do not get an unexpected recleaning. So if you have a cleaning issue, what a lot of people are doing these days still is, I will repeat the cleaning, what I've done. My normal question is then, if you were not successful in the first time of cleaning, why do you think you will be more successful the second time? Most of the time it's that you are diluting the problem and then you cannot see it after the second or the third wash anymore. So you are using the dilution to get rid of a possible contamination, what is very good to remove the kind of residues. But think of the fact there is a solution effective already on the first instant, so that you have the get right first time cleaning. Also, the clean hold time is a kind of process we are discussing often, because the clean hold time should be there to ensure the equipment is microbiologically safe, and that at every start of the production. If this is not the case, specifically for organic materials and a lot of green materials these days, you might get into trouble. And here it's a very important point. We want to secure the microbiology on the surface. So what I see still today on sites is that they do a complete re-cleaning if a clean hold time is not done. So for example, there is an equipment what is only needed once a week or once every 2 weeks because it's for a specific product. And they say after cleaning, we will store it somewhere. And when we get it out, we will do a re-cleaning in a way that we will completely redo the cleaning cycle we have done as if residues were in there. Here, it is very important to say, yeah, but you are doing a good thing because you are doing a cleaning to make the surface in a validated manner. But what you would need is only to reduce the microbiology, what is maybe on the equipment, to an acceptable level. So you should maybe run a sanitization before, or a rinse with the process water might already be enough. This can be checked with your quality department, how to work on these circumstances. And this can also already save a lot of time, because some cleanings are taking an hour or two. And if you just do a pre-rinse, that could help you to also free up times here. So these are the considerations we are getting into, where you have the possibility, just based on maybe already current knowledge or on very easy discussions, to gain a little bit of process time. And how we are optimizing this kind of protocols in practice. Also here, a case example now from a customer in France, again, a highly pigmented formulation, and where he outlined to us, he has to do a lot of re-cleanings. So he do not want to do these kind of multiple cleaning actions. He wants to get a right first time cleaning installed on the site. So we were saying we can do that, but only in case of working together. We need to get to a point where we start with the laboratory cleaning trials. Then we want to implement this on site, and of course, finally, to validate the procedure. So the lab trials we are conducting are showing you that there are differences in the cleaning performance of different products. So the trials were resulted then in a study cleaning protocol that we could outline that a certain temperature, and here a higher temperature was required, is needed. Then we are going with this protocol into the site. We are discussing how we can mimic this kind of different steps in the equipment to get a successful tree cleaning also on site. So what we did is we were looking into the equipment after production, after pre-rinse, where we still see a lot of residues, and we were outlining that we have to do the cleaning parameters outlined as it is in our protocol, but we have to monitor this as well, because we want to make sure that the defined parameters are met. And these successful field trial can then be followed by a validation run. So that means we would outline that if we are successful one time, we do not consider this as this is already acceptable. So maybe you should redo this when you have this product in your equipment the next time. Just to outline, I'm constantly getting the same result, even if I have made this product like now 3, 4, 5 times. And to call it validated is these days a topic where the authorities say you should do this kind of validation runs a number of times. So in the past, we were always saying 3 runs are needed to call something validated. But yeah, if you think of you're manufacturing every day this product and you have to clean it every day, 3 runs to call it validated is maybe a little bit too little, because you're running 360 batches a year. So that would be only a minimal one. And therefore, it is maybe good to do this a little bit more often. So in this real case example, we said we were using a 30 minutes manual pre-rinse for the elimination of the gross soil. That was not to be skipped because it was not possible for us. Then we have 45 minutes reduction from 2 to 1 cleaning cycle. And oh yes, no, we eliminated the pre-rinse. Sorry for that. Sorry for that confusion. We completely eliminated the pre-rinse for 30 minutes, and we even reduced the water consumption so that we don't have to wait for hot water a lot. So that was a pain point in this side to get the hot water for cleaning, and therefore the 15 minutes reduction of water heat up time was also very well valid for us. Overall, we reduced the cleaning time by 58%, meaning at the end that we had a very good result, and that was going into a direction that the customer outlined. This shows that a good strategy on cleaning makes it possible to run more efficiently for the production. This is what some people do not connect, that if you are getting an effective cleaning and a right first time cleaning, you are back into production much faster, and you even know you are back in production at that time of the day. You don't have to wait until an operator says, now the equipment is clean again and we can use it again. Because if you have to do a re-cleaning, they will say, I have to now do a re-cleaning. I will have to make this kind of cleaning action again, and it will take 45 minutes again. So this is what we really try to avoid. Also, the second point, what Paola raised in the introduction, is the protection of the operator and safety. And even here we know that this is a topic raised in a lot of discussions. So seeing hard to clean formulas like waxy lipsticks, foundations, titanium dioxide, cosmetic powders, mica and glitter in shampoos and conditioners, mascara, even the waterproof ones are a pain point for us very often. Masks and scrubs where you have these gritty residues, or even the sun lotions or sunscreens where you might even have an OTC, so an over-the-counter drug from the FDA consideration, where even cleaning validation applies, might be some topics. So these are very common challenges in the industry, and they are very well known in-house, and operators often know how to overcome a kind of these challenges. And if we take, for example, what we just had before here, these lipstick or mascaras, then sometimes it is the use of solvents what helps the operators to flush the equipment before cleaning with the solvent used in the products. Like these iso, or what we call it, it is called iso, but isododecane, for example, is a solvent what is used often to solubilize hard to clean soils. And they might think that this is a cheap version to go to. But we would say, if you do these kind of things, there are safety concerns, there are also environmental concerns, and what we have seen in the examples before, it might not be the most effective solution. So at the end of the day, solvents are very often flammable, so they need some extra requirements for the equipment design, or even the storage and handling of it, explosion proof or whatever. If you have it already installed on site, that's fine, but we would outline that the operators need to work with special personal protective equipments if they want to handle these solvents manually, and that even some of these solvents are toxic. So they are classified as toxic by inhalation, or even, these kind of classifications are existing. What we want to go to is to alternatives, for example, to neutral detergents for manual cleaning, where operators work with, or what is even more effective would be a CIP clean, so cleaning in place, so that you do not have a contact of the operator with the alkalinity, with the high temperatures, because then you can clean at 90 degrees Celsius with a water-based cleaning agent, what is very effective for residues, for example, waterproof mascaras. And this kind of situation is not happening if you are working with the solvents. What is an additional alternative for a detergent cleaning is that there is extensive documentation of a product available with the safety data sheets, with the user instructions, with the directions for use, ecological certifications, toxicological certifications is what you will get for a detergent, but you have to search for it for the solvent you might use for cleaning. The handling and disposable is another problematic point of the solvent, and if you discharge the solvent, this can be restricted by local regulations. This is what we see in a lot of countries, that it's even not allowed to have a certain amount of organic load into the drainage. Then sometimes incineration is thought of, and people are incinerating the pre-rinse for cleaning, and that is a very cost-intensive factor. So the alternative from our point of view is to use a kind of environmental friendly detergents, and the detergent selection can really be based on your requirements. So we have companies looking into phosphate-free cleaning, into complexing agent-free cleaning, so EDTA, NTA-free cleaning, or they need an EcoCert approved detergent so that they have a certain composition. And it is also identified that the complete product needs to be removed, and not only one of these kind of residues what is soluble in the solvent. So we want to have the entire product removed instead of only single compounds what are soluble in the solvent. So from our point of view, the cleaning times using the solvents is dedicated to the solubility of the different product ingredients in the solvent, and also we want to not have the long cleaning times of the solvent cleaning. If you have residues that are not soluble in the cleaning solvent, you might get a problem. You will do a cleaning with an aqueous-based solution in any case afterwards. So specifically formulated detergents might really be applicable for you, because you might have specific applications, for example, the soaking application, where you fill up an equipment to the top and stir it with a cleaning agent. There are specifically designed products for that, what create a little bit of foam at the top, so that you even have the layer where the air is in, so the air liquid interface touched with the foam, and that will reduce your cleaning times. And even if you talk about the cleaning in place processes where you have maybe spray balls, you have even more possibilities for savings because you don't have to fill up the equipment to the top. You only have to use 20% of the total capacity of the equipment for an effective CIP cleaning. Meaning, instead of a 1,000-liter vessel, fill up with 1,000 liter of cleaning solution, 200 liter of this cleaning solution applied with a spray ball and a circulation is enough for cleaning. So these kind of considerations is what we want to bring to your attention. Here another example with the isododecane, what is used to clean a waterproof mascara and even pigmented makeups, where these kind of pre-treatment was used in the past. So we were looking to that on site and getting the knowledge how this is processed at the moment, the cleaning procedure, so that we identified the worst case sample together with the operators, because they were telling us this product is always a hell to clean. So we really don't like when we have made this product because this is worst case for us. Then we identified the best cleaning agent like our Maxi, and we were then going to implement that on site with our assistants. So with this new cleaning regime we installed on site, we were totally going off the flammable solvent isododecane. We reduced the cleaning time yearly by 224 hours. For this customer, that means 32 batches could be produced more. And he was outlining an average value of a production batch so that we could calculate that this is nearly 700,000, so 675,000 euros as an additional product what they could produce. More than that, we looked to the wastewater savings. So also the rinsing cycles were optimized so that 70,000 euros of wastewater savings were there, and even 40,000 euros on chemistry savings, because the isododecane is also not a cheap material. So the total value delivered by only looking to this one application of these waterproof mascara cleaning was around 732,000 euros. So this is then a very good starting point to also say, is there maybe another worst case area where we should focus on, maybe even easier to clean lotions or sunscreens or whatever, so that there is still capacity to be gained. So the last point, the cost reduction and the sustainability targets should also be discussed here. And if we look to cleaning, we have very often the case that it is true that we know this kind of cleaning actions have the 4 parameters of cleaning, the so-called Zinner circle. Those of you who are dealing with cleaning are very familiar to it, that each cleaning to be effective should have a certain amount of chemistry, temperature, time, and mechanical action. For us, the variable parameters are very often chemistry, temperature, and time, because the mechanical action is given by the equipment. If you have spray balls installed, if you have a rotary jet, if you have to fill up the system completely. So these kind of things is then what gives us the mechanical action. But the cleaning time, the cleaning temperature, and the chemistry can be varied. And you can see if you make a manual cleaning, for example, the mechanical force is very high because you can apply with brushes a lot of mechanical action. But the temperature you need for the cleaning is maybe not to be that high, because if it's more than 50 degrees C, the goggles will get clogged and fumigated, or you cannot see through them anymore. This is why here the temperature might be limited to a certain amount, and even the time should be limited to what is the best cleaning time and not to make an over cleaning. And what chemistry is used is depending on the process, so that you have a safe for the operator manual cleaning agent. In a CIP situation, you might use a more harsh chemistry because you can go to higher pHs. You can have a higher temperature for cleaning, 80, 90 degrees, because no operator will be involved. And even the time and the mechanical action is again given by the equipment. So at the end, I would say there are production equipments of a non-hygienic design, or maybe non-cleanable design is maybe the better word, because if you see, this is a picture I just made 1.5 years ago, just when the pandemic starts. And this is a cleaning still taking place like this today of a mascara, where they make an, I would say, yeah, fill up and dump cleaning. So we would call this soaking of residues. And with that, also an intensive manual cleaning. So the cleaning was solvents to dissolve the residues, or even to use solvents for pre-cleaning and then to do this kind of soaking process, is not what we want to have for the future. So a targeted cleaning chemistry with an automated procedure can reduce the water energy consumption, but also the labor, so the operator's involvement in cleaning. And I think this is very important to understand, that the operator has then time to do other things. If you have operator intensive cleaning actions, the full-time equivalent dedicated to the cleaning is then really giving us a hard time, because the operators maybe want to do something more useful. The restricted chemistry and power and temperature is also another point to consider. And if you talk about manual processes, the lack of consistency. Is the operator doing the cleaning job on Monday morning in exactly the way then on the Friday afternoon? And to identify how this cleaning gets then validated is very, very tricky. To show that you are doing consistently the same manual cleaning is a kind of hard to mimic. Manual cleaning is of course very easy to implement, and you do not need any capex. So you do not need to make any capital investment to that, like if you would like to invest in a circulation pump for cleaning or whatever, because the operators are in any way there. So the solution would be then to go to a chemistry what is fit for purpose, with a high chemical power to speed up the cleaning and to free up operators' time, and to use, even in a manual cleaning, a product what is good rinsable. So the first step is here to identify if this manual cleaning cannot be moved to a more automatic one, then to go for a solution where you can go with the high chemical power, and even to have the operator safety by reviewing the cleaning chemistry you are using today. So that would be the first step towards the journey to a resource optimization. The second one would then be, of course, can I include some of the kind of manual cleaning actions into a parts washer, for example, what I have on site? I've seen situations where parts washers are on site and they are not used because, for example, there was no identification of a spray shadow testing or something like that. Also, with this kind of actions, we can help. And at the end of the day, it's very important that the parts washer are fit for purpose chemistry is used. So here we are giving also the full-time equivalent of operators will be free to do other things than the manual scrubbing of a surface. They load the small parts into a washing machine, and then they are free to do other things. We have no restrictions to chemistry because the operator will not touch it. We will have water savings because there is an optimal program what can run in the washer, and not like having a manual cleaning. What I see very often in manual cleaning situations, people are doing a manual brushing, and then they have a sink where a water line is opened with maybe hot water or cold water, depending on what you have on site. And they do the pre-rinse, the post-rinse after cleaning directly with this running loop. And if you consider how much water is going down the drain without any usage, that is also very high impact of the water spent in a manual cleaning application. With the use of an parts washer, you have also a consistent method of cleaning, and that is much easier to validate. At the end, this kind of soaking application, what we have seen before, has also disadvantages of the low mechanical action. That was the filling up of the equipment to the top and then to rinse, to dump it and to fill it up again. That is including a high water usage and a high energy usage, as well as a lot of manual action is often associated with this kind of soaking application. Also here, this is easy to implement, but yeah, you should maybe have an effective foam cleaner to boost the mechanical action so that you have a little bit of foam at the top to have this soaking application as best as possible carried out. So if you do this kind of implementation of a CIP process, so to use a better product for it, you will gain production time by having shorter cleaning cycles. You need shorter times for heating up solutions because you have normally less cleaning solutions to be heated up, and that also results in water and energy savings. At the end of the day, you are using then best-in-class detergents for the cleaning to really get more production time. So you want to optimize your cleaning process just to get more products produced on the same type of equipment. So with that, we have talked about the 3 areas or the 3 goals, what every production manager might have to get the production capacity improved, to look at the operator safety, and also to look at the sustainability targets. Because here, this kind of sustainability goals are more and more important coming up in our discussions over the last, I would say, 1.5 years, really more and more, that there are, even on the websites, targets are outlined of the companies. We want to reduce water consumption by 30%. We want to reduce energy consumption by this and this. So that is really an important factor as well. And we would be very happy to assist you in the journey to make sure you can demonstrate that you are doing the right steps into the right direction also for the future. With that, I would like to thank you very much for your attention, and we would have now a little bit of time for question and answers, and I will hand back to Paola to see what kind of maybe questions were coming in. And we were not mentioning it. I do not know if it was in the first introduction that you could type in questions in the chat function, or even, yeah, use now the possibility here.
Thanks, Thomas. Yeah, we don't have questions yet, but please feel free. So if anybody has, maybe you haven't heard or the start, because I saw someone joined later. So if there's any question at all, or if something was not clear in English, we can explain it in Italian too at this time.
In any case, I remember that at the end of the slide, you can find the contact of Thomas and Paola. Ah, okay. There is a question. Please, Paola.
Okay, so Manuela is asking, hi Thomas, thank you for the very interesting topics. I would like to ask you some more about the case study. Manuela, do you want to Manuela, vorresti ottenere dei case studies in aggiunta o hai delle domande specifiche per Thomas su quelli che abbiamo visto?
Sorry, I have some noise now in my office, but I wanted to see again the slide where was the case study with the economics and wanted just to know more about the type of the cosmetic contract manufacturer. So in which case was the case study done? No, it was okay, the slide you were before with the focus on the economics. Okay, this one. Oh, the previous?
That's the previous one?
This one.
Yes, this one, yeah.
Okay.
Because just to understand better what kind of study was conducted to see these results.
Yeah, so the situation was as follows, that there was a pre-cleaning with these isododecane, and that was a customer of ours in Spain. So he was outlining that they are doing this kind of cleaning because the operator told them the isododecane, what they use in the waterproof mascara as well, is very able to get rid of this pigmented residues in a good way. But not completely. So they were doing a pre-flush, and it was called on this equipment as a preparation for cleaning. So they made this solvent flush as a preparation for cleaning. And then they said, after that, we will do water-based cleaning in any way. And they were using not our products at that time for the cleaning afterwards. And we were then trying to identify if we can eliminate completely the solvent pre-preparation or preparation for cleaning step, and then going to use a product what is designed to remove this kind of fatty waterproof pigment soils, and have this kind of installation tested on their side. And then they said, okay, based on what we have tested with them, they have even outlined, that the reduction of the process time in a year is more than 220 hours. So that we reduced these kind of situation in a way, and we were going from an hour of from 3 hours of cleaning to 1.5 hours of cleaning, something like that. But this stands for them for 32 batches at the end of the day. But they were first of all not looking at how many batches they could produce more. They were just trying to identify what is the reduction of the cleaning time per year. And then we said, and how long does it take to make a batch on your site? And then we identified that these 225 hours are representative for 32 batches.
Thank you. And so this wasn't a cleaning place type of. It was a cleaning place.
It was a soaking application. So to fill up to fill up the equipment completely and then to dump it again. Yeah.
Okay. And sorry.
Yeah, and this is also why we get here these high chemistry savings, because to fill up the equipment in total, with the isododecane was really driving the costs here for this cleaning.
Yeah, that's true. And do you have maybe some other case study about skincare as well?
Skincare?
Yes, sure. I think we have one, Thomas, that we are finalizing right now, but we collaborated with a customer in France that is leader in skincare. And so we are just finalizing that. We can send it afterwards to you, maybe.
Thank you. Yeah.